To welcome you today's expert webinar on slope protection along railway lines, challenges, innovations, and real-world engineering practices. Railway infrastructure plays a critical role in transportation safety and development, and slope stability is one of the most important aspects in ensuring secure and uninterrupted railway operation. Today's session will help us understand practical engineering solution, modern technologies, and industry challenges related to slope protection. Now, technical team, please play World Peace Player.
ॐ नमो जीयाद्या वेद प्रतिपाद्या जय जय स्वसंवेद्या आत्मरूपा देवा तु गणेषु सकलार्थमतिप्रकाशु म्हणे निवृत्तिदासु अवधारि गोदी गुरुर्ब्रह्मा गुरुर्विष्णु गुरुर्देवो महेश्वरः गुरुः साक्षात् परब्रह्मा तस्मै श्री गुरवे नमः। पूर्णमदः पूर्णमिदं पूर्णात् पूर्णमुदच्यते पूर्णस्य पूर्णमादाय पूर्णमेवावशिष्यते। ॐ शान्ति शान्ति शान्तिः।
Thank you. It's my privilege to introduce today's esteemed speaker, Engineer Annupurni Iyer. She is the founder of Engg System Consultants Pune with an impressive professional experience of 23 years in field of civil and infrastructure engineering. She holds qualification in BE Civil and MBA in infrastructure and contracts. Her expertise in railway infrastructure and slope engineering has contributed significantly to practical and sustainable engineering solutions. We are truly honored to have her us today. We share her valuable knowledge and industry experience. Without taking much time, I invite to respected speaker Annupurni Iyer, madam, to begin today's insightful session. Ma'am, the platform is yours.
Thank you, Amrita madam. Hope audible. Amrita madam, I'm audible.
Yes, ma'am.
Okay. Thank you. So, good morning to all the faculty members, and who all have joined here. So, good morning and welcome to this webinar. So, before I begin, I would like to extend my thanks to MIT team for inviting me. So I have given or I have attended multiple events, or even attended lot of events at various MIT, that is Alandi, Kothrood, and even Loni also. But this is the first time I am interacting with this application oriented engineering institute, that is Railway Engineering College. So thank you for this opportunity, Amrita. So before I begin today's talk, I just want to convey to the students as well as the faculty coordinators that this is a very specialized branch that we'll be discussing today. So it is about, soil and its behavior. I'm sure most of you are aware of the branch that is geotechnical engineering, which deals with the soil dynamics and rock engineering, and how important its role is in the engineering is what we'll see, and we'll be just seeing a small portion of it, that is slope engineering. Okay, I'll share my screen.
म्यूट आहे ना.
अमृता मॅडम, ओके आहे ना? आवाज येत आहे, फास्ट होत आहे काही, बोलणं का ठीक
येस
आहे?
मॅम, ऑल ओके, ऑल ओके.
स्लाइड शो दिसत आहे?
Yes, ma'am.
Okay, thank you.
येस मॅम.
So as we discussed, we will be speaking on slopes. Okay, and any railway infrastructure, or say any infrastructure, not only railways, roads म्हणा, highways, roads, highways किंवा कुठली industrial development area or even a residential building development म्हणा, of course railways, airports, mining. So any infrastructure development you take, कटिंग अँड फिलिंग हा भाग असतो त्याचा. कारण आपल्याला काय डेव्हलपमेंट करायचं असेल, कटिंग केल्याशिवाय किंवा फिलिंग केल्याशिवाय आपण पुढे जाऊ शकत नाही, कारण अंड्युलेशन्स असतात. ओके, अनलेस इट इज अ व्हेरी व्हेरी प्लेन लँड. जरी प्लेन असलं तरी आपल्याला कटिंग करावं लागतं, का आपल्याला एक्सकेवेशन करून खाली फाउंडेशनमध्ये जायचं आहे. आणि हल्ली स्ट्रक्चर्सचे जे हाईट असतात ते खूप जास्त आहे. हाय राईज बिल्डिंग्स म्हणा किंवा पियर्स म्हणा किंवा ब्रिजेस म्हणा, हाईटच एवढी आहे की आपल्याला खाली जावंच लागतं. जरी प्लेन ग्राउंड असलं तरी आपल्याला कटिंग करून खाली जावं लागतं. कटिंग म्हटलं तर मग अर्थवर्क आलं. अर्थवर्क आलं म्हणजे तुम्हाला स्लोप बरोबर डील करणं हा भाग असतो. ओके, सो बिफोर इवन गोइंग टू द स्लोप्स, ॲज आय सेड, हा स्क्रीन दिसत आहे का तुम्हाला?
Yes, ma'am. Yes, ma'am.
ओके. सर, मला कोणीही तुमच्यापैकी, इट्स नथिंग टू, कोणालाही आपण जज नाही करत आहे इथे. पण फक्त आपण दोघेही बोलू, म्हणजे इंटरॅक्टिव्ह करण्यासाठी ह्या स्लाईडमध्ये काय दिसत आहे किंवा काय सांगू शकता तुम्ही बघून? अगदी कलरपासून तुम्ही सांगितलं तरी चालेल. बेसिक काय दिसतंय तुम्हाला ह्या प्रोफाईलमध्ये किंवा किंवा ह्या स्लाईडमध्ये? एनीवन? अनम्यूट करून सांगा ना, काय दिसतंय तुम्हाला? एनीवन? अमृता मॅडम, तुम्ही सांगाल काय दिसतंय ह्याच्यामध्ये, ह्या स्लाईडमध्ये?
Different types of materials, ma'am.
Thank you.
Layers
Thank you
of
very much,
different
sir.
types of.
Exactly. That is what I wanted to say. Because when we deal with geotechnical, or when we deal with soil mechanics, soil engineering, or rock engineering, this is the dynamism, or this is the infinite variance that we are dealing with. कारण सॉइल हा जो प्रकार आहे तो नॅचरल मटेरियल आहे, आणि नॅचरल मटेरियलमध्ये कुठे काय व्हेरिएशन येईल आपल्याला काही आपल्याला ते आपल्या हातात नसतं, किंवा आपल्याला खूप असा अंदाज लावता येत नाही. ऑफकोर्स टेस्ट भरपूर आहेत, आता खूप ॲडव्हान्स झालेले आहेत सगळे, जिओटेक्निकल इन्व्हेस्टिगेशन म्हणा किंवा जिओफिजिकल इन्व्हेस्टिगेशन म्हणा. पण तरीही जो मटेरियल बरोबर आपण डील करणार आहे, वेन इन डीलिंग विथ जिओटेक, हा खूपच डायनेमिक मटेरियल आहे. म्हणून आपला जो अप्रोच आहे तो एकदम स्टिरियोटाईप न असता खूपच, मीन इट हॅज टू बी व्हेरी इव्हॉल्विंग, किंवा आपण अंडरस्टँड करत करत ते सोल्युशन इव्हॉल्व झाली पाहिजे, ना की स्टँडर्ड. की वेन वी आर डीलिंग विथ से सिमेंट और RCC मटेरियल और स्टील मटेरियल, वी नो दी डिफाईन्ड प्रॉपर्टीज. आपण अगदी एवढं पण प्रेडिक्ट करू शकतो की 5 वर्षांनी, 10 वर्षांनी, 20 वर्षांनी, 100 वर्षांनी ते मटेरियल कसं बिहेव करणार आहे. बट इन केस ऑफ सॉइल इट इज व्हेरी डिफिकल्ट. आणि टू द स्केल ॲट विच आपण डेव्हलपमेंट करत आहे, किंवा रोड्स, हायवेज म्हणा किंवा रेल्वेज म्हणा, जी कटिंग्स असतात, जी फॉर्मेशन्स असतात, ते किलोमीटर अँड किलोमीटर असतं. ओके, आपण बोरहोल दर 100 मीटरला करू शकतो. जर 50 एव्हरी 50 मीटर्स वी कॅन डू द इन्व्हेस्टिगेशन, बट इट इज नॉट पॉसिबल टू डू at every 10 meter or every meter. Okay, so that is a kind of dynamic variation, or that is a kind of strata that we are dealing with. So ह्या क्रॉस सेक्शन मध्ये तुम्ही बघाल स्ट्राटा कसं how it is varying. That is, you can see the color itself. From color itself we can see it is finely laminated टू टू शेल. मग मध्येच कुठेतरी कोर्स मटेरियल येत आहे, मध्येच परत अजून एक दुसरा टाईपचा कोर्स मटेरियल येत आहे, सिल्ड स्टोन येत आहे. सो द कलर व्हेरिएशन्स आपल्याला खूप चांगल्या पद्धतीने आपल्याला जाणीव होते की बाबा कसं स्ट्राटा व्हेरी होत आहे. अँड दिस इज हाऊ, जर आपण ॲनालिसिस करायला घेतलं तर त्यापेक्षाही जास्त कॉम्प्लिकेटेड आहे. पण इट इज मोर ऑफ एन जजमेंट, सॉईल कसं बिहेव करणार, अँड अकॉर्डिंगली वी हॅव टू डील विथ इट. ओके, सो नाव कमिंग टू, हा झाला सॉईलचा एक भाग, किंवा हाऊ हाऊ इंटरेस्टिंग दॅट मटेरियल इज. आता पुढच्या याला जाऊ आपण, थोडंसं जॉमेट्रीबद्दल बोलूया. स्लोप. स्लोप म्हणजे काय आहे आहे स्क्रीनमध्ये, तेही तुम्ही बोलू शकता, किंवा तुमच्या भाषेत तुम्ही सांगितलं तरी चालेल. व्हॉट डू यू मीन बाय स्लोप? एनीबडी प्लीज अनम्यूट अँड आन्सर. कोणतरी एनी फॅकल्टी अनम्यूट करून सांगा प्लीज. व्हॉट इज सॉईल? व्हॉट इज स्लोप? Nobody wants to go? What do you mean by slope?
Inclined surface of soil, especially mountainous area, ma'am.
Thank you, sir. So whenever there is change in elevation, okay, whether it is increase or decrease, that is increase in the sense आपण जिथे उभे आहोत तिथून जर एलिव्हेशन किंवा लेवल्स राईज झाले, किंवा त्याच्यातून खाली जात आहे, ओके, इन द फॉर्म ऑफ कटिंग, तर मग त्याला आपण स्लोप म्हणतो. आणि स्लोप वाय इट इज क्रिटिकल? बिकॉज आपण नॅचरल जो फॉर्मेशन आहे, कधी कधी ते नॅचरल असतं, हे जे फॉर्मेशन्स असतात ते नॅचरल असू शकतात, पण कधी कधी काय असतं ते इट इज मॅनमेड, दॅट इज आपण कट करतो किंवा आपण भराव करतो. सो स्लोप रेफर्स टू नॅचरल ऑर मॅनमेड इन्क्लाइन ग्राउंड सर्फेसेस. ओके, नक्की कन्सिडरेशन त्याच्यामध्ये काय असतं आणि का ते एवढं इम्पॉर्टंट आहे? बिकॉज वेन एवर वी आर डीलिंग विथ स्लोप्स, ओके, वी हॅव टू अंडरस्टँड दी शिअर स्ट्रेंथ ऑफ दी सॉईल ऑर रॉक. शिअर म्हणजे काय? आपण सॉईलला जेव्हा आपण त्याचे एलिव्हेशन चेंज करतो, त्याला वरती करतो किंवा त्याला एक्सकेवेट करून त्याला खाली आणतो, आपण त्याच्या प्रॉपर्टीजला हॅम्पर करतो किंवा आपण त्याला ओपन करतो. सो वेन एवर वी आर ओपनिंग, इट इज प्रोन टू वेदरिंग माहिती आहे. सो बिकॉज आपण ॲज आय सेड, वेन वी आर opening or cutting the cross section of a soil mass, so its component is open to atmosphere, that is effect of air, water, atmospheric changes, pressure, sun, wind, सगळं काही प्रकारचे आपण एक्सपोजर देतो आणि त्यामुळे काय होतं, वेदरिंग सुरू होते. आणि हे वेदरिंग बरेच प्रकारचे आहेत. हे बेसिक आहे इंजिनिअरिंगमध्ये, हे बेसिक आहे. फिजिकल असू शकते, केमिकल असू शकते, बायोलॉजिकल असू शकतं. आणि वेदरिंग झालं म्हणजे त्याची स्ट्रेंथ कमी होत आहे. ओके, सो दॅट इज द रिझन वी नीड टू पे अटेन्शन वेन वी आर डीलिंग विथ स्लोप्स. ओके, so what are the key considerations when we are dealing with slope? It will be the shear strength of the soil or rock. It can be the soil angle and height. आता समजा स्लोप अँगल, ओके, समजा 10 डिग्री आहे, 12 डिग्री आहे, तर इट इज नॉट दॅट क्रिटिकल. बट इफ यू आर डीलिंग विथ समथिंग बियॉन्ड 50 डिग्री, 60 डिग्री, ते स्टीप झालं, सो इट नीड्स कन्सिडरेशन. सो दॅट इज वाय स्लोप अँगल अँड हाईट समजा 2 मीटर आहे, 3 मीटर आहे, तर एवढी क्रिटिकल कदाचित नसेल. So these are all the consideration that we need to understand when we are dealing with slope engineering. The groundwater conditions, how it is, whether it is at the ground level किंवा कुठल्या डेझर्ट एरियामध्ये आपण पाहिलं तर कदाचित ग्राउंड वॉटर खूपच खाली असेल. अँड लोडिंग कंडिशन्स, व्हॉट आर द लोडिंग कंडिशन्स, खूप लोड आहे किंवा अजिबातच लोड नाही आहे. सो समजा शिअर स्ट्रेंथ कमी आहे सॉईलचा, स्लोप अँगल ही खूप कमी आहे, हाईटही कमी आहे, ग्राउंड वॉटर अजिबात नाही आहे, अँड एक्सटर्नल लोड्स पण नाही आहे. सो देन इन दॅट केस we need not go for an extensive engineering in that particular slope. But it is, if it is a reverse case, we have to look into that. So these are the criticalities that we need to understand. Now these are some of the consequences when we see the first image. I would like to see bring your attention. So first image मध्ये तुम्ही बघाल, that is we have a mountain which is full of vegetation and there are very few habitats here. Second image मध्ये बघाल तर half of the vegetation has gone away and hutments have increased. So in your case you can consider, either a development of a railway line or it can be development of the area beside the railway line, either of it. Okay, so whatever I am telling, everything is related to any infra development. So it can be either roads, highways, airports, or even railways, everything, the fundamental remains the same. But now as the second image, if you see, जसं जसं घर वाढत आहे तसं तसं आपण ह्याचे व्हेजिटेशन काढून घेतले, व्हेकल्स यायला सुरुवात झाली आहे, आणि जसं जसं व्हेकल्स येतात तसं तसं आपण मायनिंग सुरू करतो, आणि मायनिंग सुरू झालं सो देन the vegetation disappears and slowly the houses has also getting disturbed. Okay, so this is a typical landslide. So all these are consequences of the human interference to the nature. Now, coming to slope engineering, it is basically, when I talk of slope engineering, it is a specialized branch of geotechnical engineering. Geotechnical मध्ये पण खूप बरेच सबडिव्हिजन्स असतात, म्हणजे स्लोप झालं, फाउंडेशन झालं, आणि आणि फाउंडेशनमध्ये पण बराच प्रकार आहे. इट विल बी आयदर शॅलो फाउंडेशन, डीप फाउंडेशन. सो मेनी aspects are there in geotechnical. In civil itself, there are 7 sub branches. In that sub branches, we have multiple sub branches. So when you talk of slope engineering, अनालिसिस खूप महत्त्वाचं आहे. व्हॉट डू यू मीन बाय अनालिसिस? अनालिसिस म्हणजे हे नाही की तुम्ही एक सॉफ्टवेअर घ्या आणि आपण ते स्लोप मॉडेल केलं आणि त्याचं हे पाहिलं. नो, इट इज नॉट दॅट. वी नीड टू अंडरस्टँड दॅट व्हॉट इज अ काइंड ऑफ स्ट्राटा देअर. आपण लास्ट स्लाइडमध्ये जे पाहिलं की ह्यामध्ये दॅट इज की कन्सिडरेशन, शिअर स्ट्रेंथ काय रोल प्ले करणार आहे, स्लोप अँगल काय आहे. सो दिस इज ऑल पार्ट ऑफ स्टडी ऑफ द साईट अँड अनालिसिस. देन कम्स द डिझाईन. मग तुम्ही सॉईल पॅरामीटर्स घ्या, जे जे कंडिशन्स आहेत साईटमध्ये तो मॉडेल करा, अँड देन यू रन the slope stability. Find out whether the slope is stable or not. If not, you have to go for stabilization measures. And then whether it ends here, no. Analysis, design, stabilization, they are just the initial part of it. Okay. And then comes the major part, that is maintenance of natural and man-made slopes. Okay. As I said, it has a continuous degradation process. How much ever you protect it, we are trying to increase that time period, or reduce the effect of weathering. But maintenance is as important as analysis and design. So slope engineering deals with preventing slope failures. So when we talk of slope failures, हे terms येतात. Landslide झाले, collapse झाले, rockfall झाले, erosion झाले. Are these same? No, all of them are different. Okay. So these are some of the disturbing images you can see for landslides. So once the rains start or monsoon starts, and it is our newspapers will be filled up with such images. Okay. Now, this is a typical line section if you see. So in this line section, I'll just explain. Instead of roadway, you can consider a railway. Of course, railways are not this critical, but still we can deal with such conditions. So you can see a typical cross section here. ओके, ह्या क्रॉस सेक्शनमध्ये काय दिसत आहे आपल्याला, हा एक ओरिजिनल ग्राउंड जो आहे तो दिसतोय आपल्याला. सो अँड it is a typical hill road म्हणा किंवा development of a railway through a hill cutting. You can imagine that way. So now to extend this existing roadway or for widening of the existing railway line, we'll have to cut. We have to cut the slopes from this location. It is coming to the towards inside of the slope, and in that case what we are doing, we are removing this base portion. हा जो कट लिहिलेला आहे आपण तो कट करून ते काढून घेणार आहे. Okay, so that is a part of the cutting process and creation of this embankment. Now on the other side, there is also a requirement of creating this roadway. Okay, इथे आपण we are seeing that the profile is only this much available. So to extend this, we have to do the filling. Okay, so in this particular section, we have a cutting and we have a filling also. And this particular road line that you're seeing, that is a green dotted line, is the groundwater level. Okay, which is the natural groundwater level which goes towards the water body on the other side. So a typical hill cut section, hill cut and fill section. So now here there are two criticalities that we have to deal with. Anybody? Some, it is very evident in this line diagram. Anybody wants to tell what is the criticality here? Which portions are critical? It is written also. You can just read it out also. So which are the portions which are critical here? Anyone wants to
White
answer that?
portion, ma'am.
Yes.
White
What's your name?
portion needs to cut down, and
Yes.
Yellow portion above the green line, ma'am.
Thank you. Very right. So there are two instabilities that we have to deal with. That is the cut portion. Okay, so because we are disturbing the original ground level, we are removing the toe of this hill. So thereby, it is the cut portion, and it is not only the cut portion, even the added original ground becomes unstable. So the whole portion, that is your wherever it is written original ground, and the white portion or the that white portion तर आता निघून जाईल. So this portion will become quite unstable, which needs to be treated. And definitely this yellow portion also, because soil का ह्या slope वरती without treatment थांबणार नाही. आपण भराव करून करून ह्या slope मध्ये without any treatment काय थांबू शकत नाही. So we have to do this filling with a treatment, and we have to treat this cutting or the original ground which has now become this original ground आता हा झालेला आहे. तर ह्यालाही ट्रीटमेंट पाहिजे आणि ह्यालाही ट्रीटमेंट पाहिजे. ओके, so thank you whoever answered, thank you very much. So now mechanics of slope failure. So we have understood that which are the portions to be treated. Now let us understand how slope fails. So when we have natural terrain which is not suitable or which is prone for failures, in addition to the climatic conditions, when I say climatic conditions, it is not only monsoon, it is also alternate wetting and drying condition. आपण स्नो एरियाजमध्ये पाहिलं, जेव्हा आपण नॉर्थमध्ये जातो तिथे स्नो आहे. सो मग what happens is in winter season, this snow material enters into the pores, and in summer season, these snow or this ice material which is now in between the pores starts melting, and it starts moving from its place. So this is again a climatic condition which we need to deal with. So we are very familiar only with rains or monsoon, but there are things beyond that as well. Then we have seismic coefficients and definitely the human intervention. So all this together, it can become a very conducive. When I say conducive, it means a favorable environment that can lead to highly unstable conditions in the hillside and the valley side. So how can the failures occur? So this is a slope failure. Okay, a typical slope failure. Then we have this toe failure, and finally we have this deep seated failure. Okay, now the most common failure, if you ask me, is the slope failure. Okay, which we most of the time mistake it for deep seated failure. So deep seated failures are not very common, they are very rare. Okay, and if it occurs in huge amount. Okay, and that causes a lot of destruction. सो अँड इट डझंट हॅपन इन्स्टंटली. डीप सेटेड फेलियर आज पाऊस पडला आणि उद्या ते फेल झालं असं होत नाही. ते आपल्याला खूप वेळा इट गिव्स इंडिकेशन. ओके, इट क्रॅक्स डेव्हलप and there is a movement in the cross section. You can see the trees tilting, the vegetation are getting tilted. So lot of indications will be given in deep seated failure which we have to be alert and we need to identify. पण आपण ते मिस करतो किंवा आपण ते इग्नोर करतो. And most of the time slow failure occurs, okay, which can be sometimes in a greater amount as well. Localized failures aside, but depending on the terrain and the climate condition, the amount will vary, whether it will be a smaller amount of small slow failure or a bigger amount. Okay, so this is about mechanics of slope failure. Okay, so now let us go for mitigation. What do you mean by mitigation? Upon slope failure, slopes pile, what is slopes? And we understood that why we need to deal with slopes when we are dealing with development, hillside pile, valley side pile. And now we are going to the protection measures or mitigation. What do you mean by mitigation and why we are using the word mitigation? Because when we are dealing with slopes, as I said, we are dealing with a lot of uncertainties, infinite uncertainties. And that is why mitigation will take action to reduce the severity. आपण त्याला 100% थांबू ह्याची पॉसिबिलिटी फार कमी असते. अँड दॅट इज वाय वी यूज द वर्ड मिटिगेशन. दॅट इज जे काय होईल त्याचा इफेक्ट कमी होऊ द्या किंवा त्याचे इम्पॅक्ट युटिलिटी एरियामध्ये खूप खूप कमी होऊ द्या. That is the objective when we are dealing with slope failures, landslide mitigation, etc. So first, what to do? We have to understand the mechanism of failure. We have to understand the occurrence, म्हणजे किती वेळा होत आहे हे, झालेलं आहे का, ह्याचं हिस्ट्री काय आहे, की काय साईजमध्ये काय रेंज आहे, सॉरी फ्रिक्वेन्सी काय आहे, म्हणजे दर 2 वर्षात होतो, दर 3 वर्षात किंवा दरवर्षी दर 6 महिन्यांनी. सो दॅट इज व्हेरी इम्पॉर्टंट टू अंडरस्टँड दी फ्रिक्वेन्सी and velocity of travel. Okay, by looking at the slope, the type of strata or the type of movement, we can understand the velocity of travel. खूप जास्त velocity असेल तर युटिलिटी एरियामध्ये पटकन येईल. जर समजा वेलॉसिटी स्लो आहे, तुमच्याकडे जागा आहे, भरपूर थांबत थांबत येणार आहे, तर मग युटिलिटी एरियापर्यंत पोचता त्याची वेलॉसिटी कमी होईल. नाव these are very important to study, because based on this is what we will be studying the or proposing the mitigation measures. Okay, triggering mechanism we need to understand, that is what is triggering this kind of failure. Kai trigger point hai. Most of the time, as I said, it is water. Either it will be due to monsoon or it will be due to freezing and thawing, जे मी म्हटलं, because of snowfall, ice presence, and then melting of ice. So it is, in a way, it is a water is a cause. But apart from that, sometimes it will be seismic, sometimes it will be alteration of the soil parameters. We don't alter, but because of weathering, it gets altered on its own. And then finally, what are its effect, whether it is a direct effect or whether it is an indirect effect. Now what do you mean by that? Now in case of railways, it is mostly direct. Okay, in case of roadways, sometimes the effect may be indirect. Okay, because the hills may be little bit far off, and the roads or highways will be, the utility areas may not be that close. But when we talk of railways, the effects are generally direct in nature. So the protection measure, the study, everything has to be planned accordingly. And what is the predictability? Predictability असणं खूप गरजेचं आहे, आणि now we are having tools also for that. Coming to landslide measures and how to do that. हे खूप when we are talking about this rockfall mitigation or landslide mitigation, okay, it is very necessary to understand the strategy of it. Okay, that is, how do we map it, त्याचं इन्व्हेंटरी काय काय आहे, ससेप्टिबिलिटी काय आहे, and hazard किती and risk किती. Then geotechnical evaluation, a very, very important parameter. Okay, in geotechnical evaluation, there are again a range of tests that we can do. It starts with geotechnical investigation, geophysical evaluation, site survey, then understand, as I said, triggering mechanism, and finally the effects. So these will form the strategy. हे सगळं स्टडी झाल्यावरती आपण स्ट्रॅटेजी फॉर्म करू की त्याला मिटिगेशन मेजर्स काय द्यायचे ते. Why I am stressing this much on strategy is because, see, when we are talking of these mitigation measures, okay, it uh, there are range of methods that you can adopt, and त्याची costing, त्याचं installation procedure, त्याचं timeline, हे सगळं त्याच्यावरती dependent आहे. It all depends on this strategy. All the other factors are depending. Now, coming to mitigation measures. So, when I talk of landslide mitigation measures, there are three, it comes under three different heads, that is earth slope stabilization, rockfall mitigation, and debris flow mitigation. Okay, so now when I talk of earth slope, okay, it is more of soil, less of rock. Okay, सो सॉईल जास्त असेल, रॉक कमी असतं, त्याला आपण जनरली अर्थ स्लोप स्टेबिलायझेशन म्हणतो. And when I say rockfall, it is, as the name suggests, it will be mostly rock fragments, either in smaller size or larger size, depending upon the rock engineering in that. And finally, debris flow. So in debris flow is the most dangerous because it will have a combination of soil, rock, and water. Okay, huge amount of water will also be there. That is why the damage that is caused by debris is far more than a earth slope or a landslide caused by earth slope or rockfall. Because त्याची velocity, त्याचं intensity आणि the volume is much higher in debris flow. Okay. So now coming to the treatment measure. Okay. So when I talk for earth slope, as I said, there are three things: earth slope, rockfall, and debris flow. Accordingly, the treatment measures will also vary. So when we talk of earth slope treatment, it starts with excavation. It's the simplest method. Okay, excavation, cutting, berm formation, and just give some light treatment measure. Okay, that is removal of the soil from the head, reducing the height of the slope, form benches किंवा berms in between, and flattening of the slopes. Then we have strengthening and slope stabilization. ते आपण next slide मध्ये बघू. Now excavation, generally in railways, this is the most adopted method of earth slope treatment, because uh, why I'll tell you, because in excavation, when you are removing the soil, when you are reducing the height, when you are giving the benches, or when you are flattening the slope, the probability of failure at a later date, you are reducing much. Okay, खूप खूप कमी होतं. आपण त्याचे मी, if you remember in earlier slides I said that we cannot say that it is 100% safe. Okay, so then how much percent safe? Okay, and in excavation procedure we can say that it may be 90% or 95% it is going to be safe. But when we go for strengthening of slope and slope stabilization, this probability may sometimes reduce. Okay, and railways generally go with a higher factor of safety. Okay, in railway the engineering goes with a much higher factor of safety as compared to roads and highways. Okay, because they have a lot of limitations, and the stake, okay, whatever at stake is much higher. It doesn't mean that the people, the value of the people who are traveling by a road is lesser, and the value of people traveling by railway is much higher, असं नाहीये ते. Okay, but the thing is, at least in road things can be controlled, but in railway the reach is not that easy, and it is a no, and a huge number of people who are going to be affected in one train. Okay, so that is why the impact factor जो आहे तो खूप जास्त आहे, स्टेक जास्त आहे. म्हणून रेल्वेजमध्ये तुम्ही पाहिलं तर फॅक्टर सेफ्टी प्रत्येक गोष्टीचं जास्त असतं. Am I audible, Amruta madam? I hope things I am clear.
Yes, ma'am.
हां, कारण मला समजत नाही ना, मला ऐकू येते का नाही येत आहे. दॅट्स आय एम चेकिंग.
Oh, ma'am. You are audible.
Thank you. Thank you. So that is why if you see in railways, excavation is, and this that is removal of soil, reduce slope, benches, flattening is more preferred than a strengthening of slopes and slope stabilization. But does that mean that the other two measures are not adopted? No, असं नाहीये. कधी कधी एक्सकॅव्हेशन सोबत आपल्याला बाकी दोन गोष्टी पण कराव्या लागतात. असं नाहीये की एकाच मेथडमध्ये ट्रीटमेंट क्लोज होईल, नाही. तर त्याला अजून आपल्याला फुल प्रूफ करायचं आहे तर एक्सकॅव्हेशन प्लस स्ट्रेंथनिंग, एक्सकॅव्हेशन प्लस स्लोप स्टेबिलायझेशन, this is which is normally followed. Okay, so this is a typical cross section. You can see that it is excavated, that is the slope is excavated, त्याला आपण gentle slope देऊ, berm देऊ and मग परत slope देऊ. Now coming to landslide mitigation measures, okay, ते काय होऊ शकते? So determine the treatment. Okay, so it can be, again for that we have to understand whether it is soil mass or whether it is a weathered rock. ओके, सो रॉकमध्ये पण बरेच प्रकारचे असतात. ओके, दॅट इज फ्रेशली फॉर्म रॉक, यु नो, मॉडरेटली वेदर्ड, हायली वेदर्ड, कम्प्लिटली वेदर्ड, रेसिड्युअल सॉईल असं. ओके, तर मग ह्याच्यामध्ये आपल्याला बघावं लागेल की कुठल्या प्रकारचं सॉईल मास आपण वी आर ट्राईंग टू डील विथ. And then we have hard rock or intact rock. Okay, so based on what kind of strata we are dealing, the type of measure will also change. Okay, so it is very simple and straightforward thing that we have to remember, that problem एक असू शकते पण treatment may not be the same. Okay, the problem may be the same for two sides. Okay, but the solution may vary because strata varies and impact factor and many other factors vary, so each site has to be dealt differently. So now coming to this soil mass and weathered rock, it will be starting with surface erosion. This is the simplest treatment that we can go. फक्त surface erosion होता है. Then we have drainage. Then it will be a little more serious or more engineered measure, that is retaining walls, and further we could have piles, anchors or nails. So it all these measures may not be the only single measure. असं नाही आहे की सरफेस ट्रीटमेंट केलं पाहिजे, सरफेस इरोजन केलं झालं नाही. कधी कधी आपल्याला सरफेस इरोजन आणि रिटेनिंग वॉल हे दोन्ही कंबाईन करावं लागतं, किंवा पाईल्स अँड अँकर्स कंबाईन करावे लागतात. सो it needs to be a combined approach. Okay, or it can be a single approach. हे कसं डिसाईड करायचं? As I said, you have to first visit the site, understand the site, form a strategy, and then determine the type of treatment. One second. So, which are the guidelines? Basically, here if you see, it is whatever this presentation has, it is IRC SP 106, which I have followed. So, but this is for road guidelines, that is Indian Road Congress. IRC stands for Indian Road Congress. I will also show you the guidelines for railways also. Okay, but here it is very systematic way they have given. That is, if you see the list of remedial measures, it starts with modification of slope geometry, then goes to drainage. You have to look at the retaining structures, and finally, as I said, the more complicated treatment, that is internal slope reinforcement, which can be rock bolts, micropile, soil nailing, बरेच प्रकारचे treatment आहेत. Okay, so now if now you would have understood that why strategy and why understanding the site and that analysis part is so important. Okay, because now what we are dealing is the design part. Okay, and finding out the solution. Okay, so that will take time unless we are understanding the analysis part. You're doing all those things, you can't find out the remedial measure. So now coming to this various remedial measures, जे काय ऑप्शन आपण घेत आहे त्याचे इम्प्लिकेशन काय असेल तर तोही बघणं गरजेचं आहे. फॉर एक्झाम्पल, this thing, if you are taking reducing the slope angle, okay, which I said is most commonly adopted in railways, that is reduce the slope angle excavation. Now what are its effects? What is the implication? Yes, by reducing the slope angle you are going to reduce the driving forces, but at the same time you understand that it's a low cost solution in terms of engineering perspective. It is unlikely to be feasible in a steep terrain. Cut surface will need erosion protection, and lastly right of way or sufficient space may not be available. Okay, नेहमी जागा मिळेलच असं होत नाही. Okay, so these are the implication that we need to understand. Now coming to installation of soil nailing, अजून एक बघू आपण. सॉइल नील करतो आपण किंवा ट्रीटमेंट आहे वन ऑफ द ट्रीटमेंट. नाउ व्हॉट आर द इम्प्लिकेशन? इट इज अ हाय कॉस्ट मेथड, स्पेशलिस्ट इन्स्टॉलेशन इज नीडेड आणि खूप स्पेशलाइज्ड ॲक्टिव्हिटी आहे ही. So these are the implications when you're choosing what option you want to go ahead with. So now this is some of the again when you go with weathered rock, what could be the treatment? Same, it starts with surface erosion, it goes to drainage. Now in surface erosion त्याच्यामध्ये पण बरेच प्रकार आहे how you can treat. You can go with bioengineering measure to wall plus bioengineering. What is bioengineering? Bioengineering is treating the slopes with natural material. Okay. Apart from bioengineering, there are other measures like shotcreting, concreting can be done. सो बरेच प्रकारचे सोल्युशन्स सरफेस ट्रीटमेंटमध्ये पण आहे. देन वी हॅव टू पे अटेन्शन टू ड्रेनेज. वेन वी हॅव ड्रेनेज, ऑफकोर्स व्हॉट आर द टाईप ऑफ ड्रेनेज? वी हॅव ड्रेन पाईप्स, डिचेस अँड ड्रेन्स, सायफनिंग किंवा बर्म्स म्हणा, बर्म्समध्ये आपण कलेक्शन ड्रेन्स देतो, कॅस्केडिंग असतात. सो दीज आर ऑल पार्ट ऑफ ड्रेनेज. रिटेनिंग वॉल्स, सो अगेन रिटेनिंग वॉल्समध्ये बरेच प्रकारचे आहेत. रिजिड वॉल्स झालेत, ग्रॅव्हिटी वॉल्स, flexible gapings, reinforced soil structure. And finally, as I said, the more specialized treatment, that is internal slope reinforcement. It can be rock bolts, micropiles, soil nails, grouting. So which one to choose? How to choose? So this comes in the analysis and the design part. So again, when we are the earlier slide was for soil mass and weathered rock. Next slide is for rock mass. When you're dealing with rock mass, the measures will again change. So it will be, rockfall protection nets, drainage, retaining walls, and finally more engineered measure, that is rock anchoring. Okay, so they, again on the right extreme right side, you can see in each protection measure what are the further options available. So it's not possible to go into details of each. I will just give you an overview of this. Now coming to drainage, मध्ये पण प्रकार असतात, surface drain and subsurface drain. Again, surface drain, when we are talking of, it is transverse and longitudinal drains. And when we talk of subsurface, it can be within the pavement or within the structures. So त्याच्यामध्ये पण बरेच प्रकार आहे. Okay, so drainage is a very important aspect when we are dealing with hills and slopes. Okay, it need not be roads only, it can be railways, as I said, any establishment or any infra development. So some of the images of installing the drain pipes you can see. Okay, so this is a typical cross section of treating hill slopes. Okay, so anyone who can tell this kind of cuttings in railway, which if you have traveled in the south part of even Maharashtra, southern Maharashtra, where you have seen such kind of images? कोणी सांगू शकेल कुठल्या रूटला आहे हा, रेल रूटला आहे? महाराष्ट्रामध्ये पण आहे. इट स्टार्ट्स फ्रॉम रोहा. आय विल गिव्ह यू वन मोर हिंट.
कोकण
Yes,
कोकण रेल्वे
exactly. Thank you very much. So it is very very familiar in the Konkan belt. These kind of pratyek starts when you exit Mumbai, and you as you enter into the Konkan belt. These cross section, these type of images are very very common. And if you get a chance, please take your students to the Konkan belt and the Konkan railway route, and take an opportunity. Take an appointment and show them the stretches, how beautifully they have done this slope protection, and they have learned it through years. असं नाही आहे की एका ह्याच्यात शिकले ते नाही. त्यांनी ते लोक खूप ओपन होते. कोंकण रेल्वे, दे वर व्हेरी ओपन फॉर अडॉप्टिंग एनी इनोव्हेटिव्ह मटेरियल, अँड इयर्स ऑफ प्रॅक्टिस they have built, they have kept on modifying. त्यांनी एक सोल्युशन चूज केलं, ते सूट नाही झालं, मग दुसरं ट्राय केलं, तिसरं ट्राय केलं, चौथं ट्राय केलं. असं करत करत आता फायनली after 20 years it has, we can say that somewhat it has stabilized, because one of the main reason is we are dealing with laterite slopes. Okay, and laterite is one of the most treacherous, tricky strata. Okay, because it is very difficult to predict its behavior, and as the combination or its the composition of laterite keeps changing at every uh, uh, meter also, you can say. every meter it can change. So that is a kind of engineering challenge that they have dealt with. So laterite soil characteristics, you can see it is porous and highly weathered, low cohesion, हाय इन्फिल्ट्रेशन रेट. इन्फिल्ट्रेशन म्हणजे पाणी भरपूर आतमध्ये जाईल, पाणी जिरतं तिथे, आणि therefore it is prone for erosion and requires effective drainage for stability. So these are some of the challenges when we are dealing with laterite, and how to deal with it, with its drainage part. Here you can see they have given catch water drain at the top. There are two drains on the surface, and there are various horizontal drains and weep holes that is provided. So these are some various drains that they have adopted and they have provided at the site. Now, apart from that, where they have also dealt with lot of erosion control measure. So all these combinations which I have explained in the previous slide, they have adopted because they have dealt with soil mass, weathered rock, rock mass. So all these they have dealt, and all the combinations, almost all the combinations you can see along the Konkan Railway route. So this is the engineering measures that they have adopted along with the slope protection. Not only this is the typical example that I'm showing. Okay, so this is again surface protection with surface drainage, slope reinforcement, that is soil nailing is adopted. So if you see what is soil nailing, it is driving nails within the slope and grouting it and ensuring that providing some reinforcement to the soil to prevent its movement. And then is that sufficient? No, we may have to give some face protection system also. So it can be a shotcrete, it can be concrete measure, it can be a bioengineering measure. And apart from that, toe protection measures are also given. So इथे पाहिलं तर toe देणं पण खूप गरजेचं आहे, because over a period of time the toe gets eroded if we are not protecting the toe. And slowly if even if we have provided surface protection measure, this toe erosion is progressive, and slowly the slope failure will progress towards the top of the slope. Now if you ask me, is this a standard solution? No, this is not a standard solution, this is a typical solution. Now depending on the site, depending on the strata, and what is the problem at the site, we will have to look at what best solution, what best combination is needed. Now these are some of the images you can see. So here on the slopes we have provided steel mesh netting, and then erosion control mats are given. Yes, some more images. The similar sites you can see on even on Karchat Panvel route also, you can see Konkan Railway, you can see Northeast Frontier Railway, you can see some more images. Yeah. So in earlier images, you had seen flexible measures. Flexible measure means they are not concrete, they are free of concrete. So we protected the slope with these kind of nets and mats. Now these images are more with shotcreting and soil nailing. Now which to adopt, depending, as I said, it depends on the strata. Okay, if it is soil with high water absorption capacity, or high infiltration rate, then it is not advisable to go for flexible. Okay, it is it is advisable to go for flexible. Shortcut is not advised over there. If you have a moderately weathered strata, or you have a kind of less water absorbing material on the surface, rock surface is there, then you go for this kind of shotcreting. Some more images you can see. Yes. So this is a rockfall, a typical rockfall protection nets that are being installed at the site. You can see. So these are installed by expert climbers, okay, who will have the the safety protection measures. They will go to the top. They will first create a safe access for them, and then only start such excavation and even laying works. So these are specially very expert jobs that we can say. We need highly skilled labors for this. So these are installation of rockfall barriers, we can say. So okay, this is a typical cross section of a rockfall barrier. So barrier is basically we have this kind of if you would have seen traveled along Mumbai Pune Expressway, you would have seen these kind of barriers which have been placed all along the route wherever there is rockfall zones. They have placed such kind of barriers. So these are basically preferred at locations where we can't judge the movement of the rockfall. That is, we are dealing with a high slopes, and the trajectory of the rock movement is not easily predictable. We'll have to go for these kind of rockfall barriers, or even if you can't reach those accessible area, those areas are inaccessible, these barriers are quite useful. A typical case study of road development here you can see. This is for NH connectivity of Char Dham in the state of Uttarakhand. So this was basically for embankment. So till now we were talking about slopes. So this is about embankment stabilization. So this was the Char Dham. You can say Yamunotri, Gangotri, Kedarnath, Badrinath. And the stretch that we are in discussion is the Rishikesh Dharasu section. So the client is more than BRO, and the contractor was ABCI. And so what was the scope was slope stabilization. Approving authority was IIT Bombay. So here you can see this is a typical crossing. Just imagine is to be a railway embankment, extension. This we are talking about is a roadway extension. So here the cutting or the filling, not cutting, the filling was about 15 to 20 meter, and the space available was not more than 4 meter, 4 to 5 meter. The existing slope was say about 65-degree. Okay, so we had to use the space that was available, that is 3 to 4 meters, and stabilize this high embankment. So how did we do that? So the area in discussion was steep slope, and the valley side was along the river Bhagirathi. The protection was required to support road widening. So what was the system adopted? The system here that we adopted was an advanced version of reinforced soil wall, that we call it as shored SMSC wall, that is shored mechanically stabilized earth wall. These are the guidelines which are available. So this is given by FHWA, Federal Highway Administration. So typical cross section, if you can see, so if you can relate it with the first line sketch that we had given. So on the right side, that is on the valley side, so we had a river, or here also we have the river Bhagirathi that is flowing. And what we have to do is, this is the existing traffic lane, and we have to form a new traffic lane, or in your case it can be a new railway line that needs to be extended. So how do we protect it? We don't have an sufficient base width here. The height that needs to be stabilized is about 15 to 20 meters. So the base width will be somewhere around 14 meters. Okay, so 20 into 0.7, a thumb rule if you say, it will be about 14 meters. In case of railway, it will be much more. It will be about, base width is about H. Okay, that is, if it is a 20-meter high cutting, you need base width of 20 meter, which is not available here. So how did we stabilize it? So first we have anchored the existing slope, okay, so that the lateral earth pressure from this side is reduced on the retaining structure. So nail it, shore it, and then create a new structure and connect these two. So this is again a quite specialized engineering, that is SMSC, that we call shored mechanically stabilized earth structures. Some of the images now, what did we do in design submission? We did the analytical calculation of selected heights. We analyzed with the software, and also we did the detailed calculations. So this is a typical cross section that was given. So here you can see that is the existing roadway, and how did we extend it for the new roadway. So we stabilized it with the anchors, the existing one, and slowly we have built an embankment from the base. Okay. So here we gave a ground improvement with geocell. So these are all solutions with a family of geosynthetics. It can be geocell, geotextile, gabions, geogrids, drainage composites. So there are it's so when I talk of geosynthetics, it's a family of material which can be used for various applications. Okay, and these are very friendly with the environment, and hence the name. It starts with geosynthetics. So the existing embankment here you can see was nailed, and slowly this embankment from the base has come up layer wise. The red lines that you see are geogrids, which gives the strength to the embankment, and Gabion was adopted as the fascia. So if you look at again the design part, it's quite extensive. Okay, so we have to look at a comprehensive way of doing it. First you check the stability of the existing embankment, then you model the new embankment and do a combined check. Okay, so the checks will be sliding, overturning, bearing capacity, and global stability checks. And when you look at the foundation, no detailed preparation is needed, but yes, as it was rock at the base, we need not go for a detailed foundation preparation, but still, whatever is a minimum preparation was needed. We gave a firm base form of geocell, and then the vertical anchors were provided. Some of the images you can see. Yeah, so this is the plan view you can see. So इथे आहे भागीरथी river on your extreme left, and this is on the plan view. You can see how the extended embankment is going to take the shape. Some more images. So here you have on the fascia, you have this Gabion fascia, and then we have geotextile as filter media. And these elements that you can see are geogrids that are provided for reinforcement. So anchoring, the anchors that you had seen in the uh, cross section. So they are given on the hillside, and then these are the layer wise construction that is being done. So slowly it has come to the top surface. So here you can see the bus that is moving. So this is the existing embankment, and then slowly the new embankment is coming up. So this is the completed view of the embankment. That is, Gabion is acting as a fascia, and here you have these kind of geogrids that were provided as a reinforcement, and these are the anchors that were driven on the hillside. So this is a completed structure. The same replica can be taken for railways, but yes, there are certain limitations in railways because we have to go with zero tolerance for any settlement. So these kind of direct placement of the track may not happen. Of course, if the track is a few meters away, okay, then we can look at these kind of measures in case of railways, or even the approach embankments can be constructed. So these are some of the images of a slope stabilization works at Palakkad for KSTP. So here you can see the previous image. So kind of rock cutting is there on the cutting side, and then we have planned the protection works with anchoring, and further a surface treatment is given. Now surface treatment, as I said, it can be either flexible or it can be rigid. So some view of the images. This is for NH. So shotcreting is being done and anchoring is done. So I have shown you both the options, that is with flexible fascia and with concrete fascia. So this is with the rigid fascia, or we can say semi-rigid. Okay, so where you have, as I said, less water absorbing strata, you can go with these kind of solutions. Where we have more water absorbing absorption strata, or where the silt content is higher, we can go with the flexible option. So this is a collage of the railway, the standards that we generally adopt, the state of art guidelines, the engineering guidelines for landslide mitigation on roads, and FHWA manual. So when we talk of slope engineering, okay, it has to be a totally integrated approach. Okay, first it starts with art. Art means we need to first be able to judge how the ground conditions are varying, whether the erosion is going to be, progressive, whether you have seepage, water seepage is there, what are the construction constraints, how you can adjust the slope, whether you can take the space availability is there, and what is the access, how to sequence. So all this understanding and judgment needs to be there even before you work on the solution. So understanding the problem and what are the constraints at the site, and then crafting the solution. Then here comes your science and engineering. Science remains the same. Okay, it is, it is 1 plus 1 equal to 2. That is what is science, that is what we will be able to do. So those equations, everything, and the analysis part, modeling part will remain. And of course engineering, it is again very important to understand the conditions what the site will be experiencing, whether it is a dry condition. Of course, when we are dealing with hill slopes, we have to look at the saturated and the seismic condition, as well as the construction stage stability also needs to be checked. And what are the factor safeties? So these are all these combined together is the approach that we need to adopt for slope engineering. So it is a multidisciplinary approach. So when you are dealing with such kind of slope strata, whether it is railways or it is roadways or highways, you need to understand and involve, okay, the geotechnical engineer, hydraulic engineer, transportation, structural, and definitely drainage needs utmost care. So it is not just a structural engineer's work or a geotechnical engineer's work. You need to pay attention to all these aspects when we are dealing with these kind of problems. So solution requirement, generally it is permeable and free draining, because already we are dealing with a lot of water pressure here. So better that the solution is free draining. It has to be as environmental friendly as possible, flexible, and the speed of construction has to be fast. Especially in railways, the speed has to be quite fast, because the working window in when we are dealing with, open lines is very less. Okay, of course for new lines it is fine, but if you are dealing with open lines, it has to be very quick. Even that all these factors are very important when we are dealing with an open line construction or any open line development works. So this is collage of the standards that we generally follow for approach in case of slopes and slope engineering. Now coming to, I will also show you the guidelines that we follow. So in case of railways, you can see. So I hope you would have heard of the organization RDSO. So what is RDSO? Anybody? So this is the research design wing of railways, basically. So they are the research wing, okay, who the railway zonal office, even all the offices related to railways, okay, are referring to them, RDSO, that is Research Design Standard Organization, and they generally release such guidelines and specifications for railway formations. This is one for guideline which is for slopes, and here you can see what are the factor of safeties and how to approach in case of slopes. They also ask us to refer to Indian IRC standards as well, but yes, it's based on engineering judgment. So here's our pilot, the same guidelines ahead: soil exploration and survey, then what are the suitability of subsoil, the same approach that we saw in IRC is here also. Understand the design formation and specification of formation layers, what is the application of geosynthetics in railway formation, how to do the slope stability analysis, earthwork, quality of earthwork, then how to do the erosion control. So as we said, how to select the erosion control method, what is the protection of slope cutting. As I said, the approach remains the same. Only thing is these standards are more specific to railways. So all the details are provided. It's a very comprehensive and impressive document. So you can, whoever are interested can download it. It's available in the internet, or you can go to RDSO website and download this. So they have very clearly given for railways what could be the approach that can be taken for slopes and ground improvement. So as I showed you, the geocell we saw in the case study, the same geocell is used for ground improvement. We had used in the case study. You have seen. So these are PVDs for ground improvement. Then how to deal with slopes. So this, as I said, very comprehensive document with case study they have given, where it is adopted and how it is performing. All those details are provided in this document. So this can be used. Factor of safety is also given here. That is what should be the factor of safety for slope failure, what should be at the end of construction stage, that is at the temporary stage, and when the moving train is there. So 1.6 should be ensured for slope stability of smaller embankments of height up to 4 meter. So details are given. What is the computation procedure? Bishop's simplified method. So most of the details are covered related to slopes. So I would encourage to faculty as well as students to go through this. It's given in a very very simple language, so you can very well understand that. So that's it, madam, from my side regarding slope engineering. So any questions we can take up.
Is any questions?
No, madam.
Thank you. Thank you
Uh,
so much, ma'am.
Nivas Patil has raised his hand. Want to ask any
Ma'am.
question? Yeah. Nivas Patil. Okay. Yeah, man. Please.
Hello, ma'am. I have a question.
Yes, please. Police.
This is Assistant Professor Sandeep Jagta from MIT College of Railway Engineering, Barsi, ma'am.
Yes, sir.
Actually, I have a question. What is the effect of a cyclic stress, which basically generated by the moving train
Hmm.
on the ground of existing ground and
Yes.
existing fracture in the body of that particular slope portion?
Definitely. So these cyclic loads are definitely need to be considered in the design analysis. So over a period of time, that is why if we again, I will go to the Konkan Railway as an example. So the formations are on filled up strata or on the strata which are strengthened by various formations. So there will be the kind of dynamic loads that we say, that we consider in the design when we are dealing with railways, especially when in highways we deal with live loads, but when we come to railways it is live loads and dynamic loads. So that needs to be considered in the design. So effect is there. If you ask what effect, yes, there will be loosening of the strata, or the pores, the existing pores or the cracks are there, that will definitely widen, or time the soil will try to disintegrate, okay, over a period of time. So that effects definitely needs to be considered in the design aspect.
Okay, ma'am. Thank you, ma'am.
Thank you, sir. Any more questions? Madam, Amrita madam, you can, over to
Thank you
you.
so much, ma'am, for such an enlightening and practical session on slope protection along railway lines. Your valuable guidance and real world experience have definitely enhanced our understanding of railway infrastructure, safety, and engineering practices. I would like to thank you all participants, faculty members, organizers, and technical team members for making this webinar successful. Thank you everyone for joining us today. Have a wonderful day ahead. Technical team, please play Pasaidan.
Thank you, ma'am. Question.
Yeah, Amrita, can we exit? Can I exit?
Yes, madam. Now I conclude the end of session.
Yeah, thank you.
Thank you.